Welcome everybody, it's Amell, and today we're going to solve bag of tokens. You have an initial power P, an initial score of 0 points, and a bag of tokens. Each token can be used at most once, has a value tokens of I, and has potentially two ways to use it. If we have at least tokens of I power, we may play the token face up, losing tokens of I power and gaining 1 point. If we have at least 1 point, we may play the token face down, gaining tokens of I power and losing 1 point. Return the largest number of points we can have after playing any number of tokens. Okay, so in this problem, we have a bag of tokens, and what we can do is that we can play with the token in two ways. One way is if we have power that is bigger than or equal to the value of the token. If that's the case, we lose that amount of power or the cost of the token, and we gain 1 point. The other way is if we have at least 1 point. If we have at least 1 point, then we can gain tokens of I power. So we can gain the power of a token. However, we lose that point. We lose 1 point. So what we have to do here is that we have to return the largest number of points that we can have after playing any number of tokens. So for example here, example 1, we only have 1 token, and the value for the token is 100. And the power that we have is 50. So you can see that this is not enough to get a point, because the value of the token is 100, so the power that I have is less than the value of the token, so I cannot get any points, so the output is 0. Example 2, you can see that the power that I have is 150, and I have 2 tokens, so the output is 1, so the number of points that I get, the maximum number of points that I can get is 1. Why? Because the power that I have is 150. So what I can do is that I can give 100 power for this token, and then that will give me 1 point, and then I'm going to have 50 left, and 50 is not enough for the next token. So the maximum number of tokens, the maximum number of points is 1. Now example 3. You can see here that we have 4 tokens, and the power that we have is 200. So what we do is that we get this token with value 100, so we get a point, and now we have 100 points left for power. We have 100 power left. Now we only have 3 tokens remaining and 100 power, so it's not enough, because the value of this token is bigger than 100, the value of this token is bigger than 100, and also the value of this token is bigger than 100. So what I can do is that I can take the point that I have, and I can exchange this point for a token. And what I should do is exchange this point for the token that has the greatest value. So I will exchange this point for this token that has value 400, and then I have 0 points, but now my power is 400 plus the 100, 500. Now with 500 power, I can buy this token, so we'll get 1 point, and then 500 minus 200 is 300, so I have 300 power left, so I can also buy this token, that will give me another point, and that's why the maximum number of points that I can get in this example is 2. So how can we solve this problem? Well, if you pay attention closely to the examples, you can see that the data is sorted in ascending order. So what we should do is sort the array. We want to use a greedy algorithm. A greedy algorithm makes locally optimal decisions at every step. In many problems, a greedy algorithm does not usually produce an optimal solution. But in this problem, it produces an optimal solution, because we want to maximize the number of points that we can get by playing the tokens in these two ways. So what we do is that we sort the array of tokens, and we maintain two pointers, I and j, because I will always point to the token that has the smallest value in the tokens, and j will point to the end initially, so it's going to point to the token that has the largest value. So what we want to do is that in order to maximize the number of points that we can get, we want to get points by taking power or giving power for or the least amount of power that we can give. Similarly, if we have no power left, we want to get more power if it is possible, and we want to get the biggest power that we can get. So we have to get it from position j down. So we're going to maintain a search space. So we have I initially at the beginning, j at the end. The data is sorted, and we can maximize the number of points by choosing greedily in order to maximize the power and also maximize the number of points. So without further ado, I'm going to show you how to write the code. So the first step is to sort the array of tokens. So arrays.sort tokens. So now the array is sorting ascending order. So I have to have a few variables. I need integer max points, so that's the maximum number of points that I can get. I also need points. This is going to be the number of points that I have during this iteration or during the current iteration. I also need to have I, and I gets a value of 0 because initially we want to maintain I at the beginning, right? And j is going to be at the end. So j gets a value of tokens that length -1. Now I need to examine each token, so I need to have a while loop. While I is less than or equal to j, when the pointers cross, that means that I have examined all the elements. So that's why the condition has to be I is less than or equal to j. At the end of the algorithm, I'm going to return the final result, which is max points. So this is the maximum number of points that I was able to get by playing with all the tokens. So each time I want to play with a token. So if I read this condition here, you can see that if we have at least tokens of I power, that means that the power that I have is bigger than or equal to tokens sub I. In this particular case, I want to check if the power is bigger than or equal to tokens of I. I'm using I because I is always pointing to the smallest, or to the token that has the smallest value. So in order to maximize the number of points, I always want to exchange power for the token that requires the least power, for the token that requires the least amount of power. So if that's the case, if we have at least tokens of I power, then what happens? We lose tokens of I power, as you can see. So power minus equals tokens sub I, and we increment I because we have processed this position I, and we also gain 1 point, so plus points. So each time we gain a point, we want to check, we want to update max points, because maybe the number of points that we were able to get this time is better or bigger than max points. So we can say max points gets a value of math.max of max points and points. Now the next condition is the following condition. If we have at least 1 point, so let's say that this condition is false, but we have at least 1 point, then what we can do is that we can gain more power. So else if the number of points that I have is bigger than 0. That means that I have at least 1 point. Then I can exchange the point, right? I can lose 1 point, but at the same time, I'm going to gain token survive power. And how much power do I want to get? I want to get the maximum amount of power. To maximize the power in order to maximize the number of points. So I should get the one at position J, right? So in this case, I'm going to gain token survive power. So power plus equals tokens sub j minus minus. So I get the token that gives me the biggest value. So I'm going to get a power from this token, and then I have to decrement j after that. So I'm using the PostDecrement operator. And what else? Then I'm going to lose 1 point in this particular case. So minus minus points. So these are the two conditions, or these are the two ways in which we can play with a token, right? So we can use a token in these two ways. So if this is not true and this is not true, that means that we have found the maximum number of points that we can get, because we cannot play anymore. So we can simply break out of the loop, and then we return the max points. So if I run the code, okay, I'm going to submit my solution. Alright, so it's working perfectly. So the time complexity is dominated by the time to sort. The time complexity is big O n log n, where n is the number of tokens. And the space complexity is big O of 1, because we're only using a few extra variables. If you like this video, please press the like button. Don't forget to subscribe, and see you next time.